Now it's going to get a little bit dull and tedious if all we ever do is convert from binary to decimal and decimal to binary using pencil and paper. It's okay at the beginning in order to just get a bit of an understanding of floating point numbers. But really what we want to do is to get the computer to do all the hard work for us. Now that's what I've done here. I've written a few programs that allow us to do the conversions in Excel using Excel VBA. So if you head down to the resources section, you'll see an Excel spreadsheet, and you can open that up, and there's only one tab on it. It's called the Tools tab, and we've got three different tools here. We've got one for conversion from binary to decimal, one for the conversion from decimal to binary, and there's a third tool here that's called Floating Point Converter, which does both the conversions in the same form. Now, you have to make sure that your macros are enabled in order to run this code. So if they aren't already enabled, you can go in, if I give me a second here to find the correct screen, there's the screen here. So you can find them if you head in to File, and then you can go to the Options tab. In that Options tab here, under Trust Center, you're going to have Trust Center settings. And in here you've got the different settings for your macros. So you can click on, I have it clicked on here, okay, because I've written the macros are on my machine, but it's up to you to decide on what level of security you need, but I'm running it here. So that's one thing that you need to set up. Another thing that you need to do is that if you want access to the actual code, now I'm no Excel VBA guru, but the code's there and it's available to you. You can always have a look through it if you're interested, and you can expand on it, and you could actually write it a bit better than I write it. Now, if you want to have access to the code, you need this Developer tab. So in order to get the Developer tab, you have to go to File, and again into Options, and you can head down into Custom Ribbon. And you have to make sure that we have the developer section. So this developer section may be over here, and you might have to press the add button to add it in. And also you just have to make sure that the button here is actually clicked, because if I unclick it, then this developer tab will disappear. So once you've got that, press OK, you'll have the developer. And this will give you access to the code if you want to go in and have a look. So in order to go in and have a look, you can press developer and you can view, you can put in view code, or you can press the design mode, which will allow you to then just double click these and drop into look at the code. But you don't need to look at the code in order to understand what's going on. So let me just get this back to a better screen. Okay. So first of all, we're going to be looking at this binary to decimal annotated. So if you double click on this, you'll see that we've got the floating point binary to decimal converter tool come up. So let me talk you through this. What we've got is a 32-bit floating point single precision binary number. We've got our sign bit in yellow, we've got our 8 exponent bits here, and we've got our 23 mantissa bits. Now we can change these here, and you see that as we change them, we just click on them, and as we change them, you see that the actual conversion is done, and this is the decimal equivalent of this floating point number. So let's just put in a number that we've seen before. So we've got the number 2 here. Now you'll see down at the bottom we've got the number 2, and this is the final result. Now I've added in a few extra sections here so that we can see exactly how the conversion process takes place. Now we've already seen that we can adjust the sign using this bit here, so you can see that that becomes minus and the value becomes minus, and also the final result is minus. And the way to work the result out here is in the brackets we've got our -1. So when I change that, all of those change from minus to positive. That's the sign bit. And now we've got the exponent bit here. And of course we can see that the exponent bit, if I click on it here now, is copied, the 8 bits is copied to this section here. So these 8 bits are the number 128. We then take away the value of our bias, which is 127, and we get a value of 1. And this tells us that it's a normal number. Now in this instance, the mantissa is all 0. But if we were to change the mantissa, so we make the mantissa an actual value, so we'll give this a value. And they say it's the one that was seen before, it's the value of 0.5. So this is going to be 2 to the -1, which is 0.5. And you'll see that the value of the mantissa has been written down here. Okay, so there's just one value from the 23 bits that have gone to a value of 1. And we've got our final result here, which is going to be the sign, which is +1, times the exponent, which is 2 to the power of our exponent value, which is 1, times the mantissa, which is our 0.5, plus the value of 1, which is our assumed or our hidden bit. So the final answer is going to be our 2 times 1.5 times 1, which is a value of 3. So this tool allows us to go in and put in whatever number we want, and we can work out exactly what the decimal equivalent is. And of course we can clear it, and you can close the form as well. Now this is really quite handy because we can go in and work out the largest possible number that we can generate using our floating point number. So let's have a look and see what the largest possible number is going to be. So we're going to have all of these are going to be values of 1. Apart from this one, we just leave that. And then all of the values here for our mantissa are going to be values of 1. And you'll see that the number is increasing here. So if we go all the way up to the top, we'll see that we can generate the largest normal number. And this is the largest possible number that we can generate using our 32-bit single precision floating point numbers. And this is the value in decimal. Now we can also mess about and we can find the value for the smallest normal number that we can generate. So the smallest normal number that we can generate is going to be a value of 1 here, and all of these are going to be a value of 0. Now don't worry if you don't understand why this is the case for the moment. This will all become clear as you continue to work through your floating point numbers. So here is the smallest possible normal floating point number, and this is it. This is it here in our decimal. So it's quite a useful tool, and you can mess about, and whenever you go to work through the examples in the quiz, you can always use this as a check to see that you've actually done it properly. So this is the tool that we're going to use for the floating point binary to decimal conversion. So in the next video we'll have a look at the other tool that we're going to use, which is going to be the decimal to the floating point binary conversion. So thank you for listening to this video. I'll get you in the next video. Goodbye.